Hey, what's up, guys? Mr. Moore here. Let's do a little review for the quiz tomorrow. So, question 1. Soccer ball is kicked with an initial velocity of 50 meters per second at 35 degrees above the horizontal. Find the horizontal and vertical component. So this is part 1. This is finding the components. So my original velocity is going to look something like this at 50 meters a second at 35 degrees. And I'm asking you to find the horizontal component. In order to find the horizontal, you need to multiply the initial times the cosine of the angle. So that's going to be 50 times cosine of 35 degrees. And then that should give you your horizontal component. If I wanted to find my vertical component, so my vertical component is going to be the initial times the sine of the angle. So that's going to be 50 times the sine of 35 degrees. Now I don't have my graphing calculator here, so I'm not going to be able to punch in those numbers for you. So question 2. A rocket is fired with an initial velocity of 100 meters per second at an angle of 70 degrees south of the horizontal. All right, that's important right there. What are the vertical and horizontal components of the initial? So let's draw this. A rocket is fired with an initial velocity of 100 meters per second at an angle south of the horizontal. So this is going to be the 70 degrees right here. And then the 100 meters per second, that's my initial. Let's find the horizontal piece. So same thing as above. It's going to be 100 times the cosine of 70 degrees. And then when I want to find the vertical component, that's this arrow right here. It's going to be 100 times the sine of 70 degrees. Okay, that's number 2. Moving on, question 3. Alright, let's see here. So question 3. A ball is kicked with an initial velocity 20 meters per second at an angle theta above the horizontal. If the rocket's initial horizontal component was 15 meters per second, find the vertical. So in this case, it's going to help to draw it first and then see what we can do to solve. So a ball's kicked with an initial of 20 meters per second, so that could be my initial right there. Now I don't know the angle, but that's okay. We don't need it here. I am also told that the initial horizontal is 15. So there's my initial horizontal. And they want me to find the vertical. So if I want to find the vertical, well, the vertical there is really the same thing as the vertical here. And what I can see is that this is a triangle, so I can use Pythagorean theorem. So in the end, I can just say that the initial squared is equal to the horizontal squared plus the vertical squared. So 200 squared, that's 400. 15 squared, that's 225 plus ay squared. All right, subtract 225 on each side. And then that's going to give me 175. And if I take the square root of that, I'm going to get, so let's see, 175 is equal to ay squared. And in the end, take the square root of each side. And you're going to get that ay is equal to 13.2 meters per second. All right, so that's questions 1 through 3. So let's move on. 4, 5, 6. Don't save that. Let's make these size 18. All right, so question 4. A golf ball has an initial velocity of 20 meters per second and an initial horizontal of 15 meters per second. Find the resultant. So in this case, I'm giving you the components. So it has an initial vertical of 20 meters per second. So that would look something like this. That's 20. It's got an initial horizontal of 15. All right, and then I want you to find the resultant. Well, again, we're just going to use Pythagorean theorem because the vertical there is kind of like the vertical here. So in this case, it's just going to be the resultant is equal to the horizontal squared plus the vertical squared. So that's going to be a squared equals 15 squared plus 20 squared. 225 plus 400. So let's do 625, take the square root of that. So a squared equals 625, and then we take the square root of each side. We get that the a is equal to 25. So this is our resultant. When we add those two components together, we get this right here, 25, and that's meters per second. All right, now I also need to find the launch angle. So in this case, you can use sine, cosine, or tangent because you have all three sides of the triangle. So let's just use tangent. Tangent of the angle, and that's this angle right here, is equal to opposite over adjacent. So in this case, tangent of the angle is equal to the opposite, which is the green side, the vertical side, which is 20, divided by 15. And when I want to find the angle, I have to take the inverse tangent. So the inverse tangent of 20 divided by 15. Now I don't have my graphing calculator, so I'm not going to be able to do that one for you guys. All right, question 5. A long jumper has an initial horizontal velocity of 18 meters per second. And an initial vertical of 18 meters per second. Find the resultant. So initial horizontal, that's 18 meters per second. An initial vertical of 18 meters per second. Find the resultant. All right, once again, this can be Pythagorean's theorem because the 18 there is the same as the 18 here. So a squared equals 18 squared plus 18 squared. So that's going to be a squared equals 324 plus 324, which is 628. Now if we take the square root of that, we should get a is equal to 25.45, so I'm going to round that to 25.5. That's meters per second. Now find the angle. So again, we can use SOHCAHTOA. We can use any one. In this case, if I want to find this angle, I'm going to use the sine. So sine of the angle is equal to opposite over hypotenuse. In this case, the opposite is 18. The hypotenuse was 25.5. So if I want to find the angle, I need to take the inverse sine of 18 divided by 25.5. And I don't have my calculator, so I can't do it for you. All right, number 6. All right, a rocket is fired with an initial velocity of 45 meters per second. So that's not the horizontal and it's not the vertical. That's the initial. All right, it has a horizontal component of 25 meters per second. And then I want you to find the angle. So can you find the angle? If I just give you these two pieces, can you find the angle? And yes, you have to look at sine, cosine, or tangent. Which one uses the adjacent and the hypotenuse? And that would be the cosine. Cosine of an angle is equal to the adjacent divided by the hypotenuse. So the cosine of an angle is equal to 25 divided by 45. So if I want the angle, I have to take the inverse cosine of 25 divided by 45. And that's going to be number 6.